Okay, so here I'm going to demonstrate another example of the reduction of order. Hopefully I can make this video shorter than the last one. However, I'm not going to go into as much detail as I did with my other video. So we know that y1 equals to t raised to the negative 1. So then we say that y equals to v times y1. Y equals to, I'm going to write the t to the negative first power first times v. Okay, so that equals to y. Then y prime is going to be negative t minus 2 v plus, I'm gonna take the derivative of the first, leave the second, plus leave the first times the derivative of the second. Okay, so that's our y prime. Y double prime is going to be 2t to the negative 3 times v plus plus negative t to the negative second power v prime. So I took care of this. Now I'm gonna take care of this. So plus it's gonna be negative t to the negative second power v prime plus t to the negative 1 times v double prime. Okay, so just to make this look nicer, I'm gonna combine like terms. So y double prime, let's see, so once again I'm gonna write in the highest order of v. So we have t, so we have t to the negative 1 v double prime. Okay, so we took care of this. Now this is going to be minus 2t negative 2 v prime. Okay, so that combined that plus 2t negative 3 v. Okay, so now I'm going to substitute this into the equation. So we have 2t squared. So once again I put all the t's in front of the v's because that makes it, as you will see, it's going to get a little bit messy, but so that helps it a lot to put the variable like t or x in front of the v. Okay, so 2t squared. Now I'm going to write this whole thing here, t negative 1 v double prime minus 2t minus 2 v prime plus 2t minus 3 v. Okay, so I just made that substitution, and I'm going to write under it. It's just much easier to recognize what's going on. Minus t minus 2 v plus t minus 1 v prime. Okay, we have minus 3. Now the y, what did we make y? We made it y equals to t negative 1 times v, so it's going to be t negative 1 v. Okay, and everything here equals to 0, so I'm going to do this substitution distributive property. So it's going to be 2t v double prime. Then we're going to have minus 4. T is going to go away, so 4 v prime. Okay, then we're going to have plus 4 t to the negative 1 v. Perfect. Okay, then we're going to write plus negative t negative 1 v. Okay, this is going to go away because t times t to the negative first power is t to the 0, which is just going to be v prime. Okay, so we got rid of that, and then we have minus 3t negative 1 v all equals to 0. So now once again we want to, if we want to get rid of v, so if we didn't get rid of v, we did something wrong. So here we have a v, here we have a v, and here we have a v. Then we have v prime, v double prime. So what's the sum of these? We have 4 minus 1 and minus 3. The sum of it equals to 0. Right? 4 minus 1, that's 3 minus 3, that's 0. Okay, so then we have 2t v double prime minus 4v prime, okay, plus v prime also equals to 0. So then we could rewrite this combining like terms. 2t v double prime this is going to be minus 3 v prime equals to 0. Okay, and from the last video, if you remember, we're going to make w equals to v prime, so w prime equals to v double prime. We're going to make the substitution here. It's going to be 2t w prime minus 3w equals to 0. Okay, and once again, we're going to do this by using separables. So first of all, write this here. We have 2t minus 3w equals to 0. W prime is simply dw over dt minus 3w equals to 0, right? So I'm going to move this here. So we have 2t dw dt equals to 3w. Okay, let's multiply both sides by dt. Okay, so that gets rid of dt here. So 2t dw equals to 3w dt. Now we have dw here, but we don't have any w's here. That's the problem. Now we have a dt here, but we don't have any t here. So let's make that. Let's take care of that. Okay. So first of all, let's divide. I'm gonna divide this side by 2t. So I divide both sides by 2t. So we have dw equals to 3 over 2. We have 1 over t, right, times w dt. Now we have a w here, so we can divide everything here by w. Divide this side by w. So we have 1 over w equals to 3 over 2 times 1 over t dt. Okay, so then we could take the integral of both sides. So this one will be ln of w equals to, so this is a constant, so it comes out 3 over 2 ln of t plus c. Okay, so if we raise both of these sides to the e power, we get w equals to, and if you know your natural logs properties, you know that this is actually the power of t. So we're gonna get the t raised to the 3 over 2, and also if there's a plus here, that means that this simply means e 3 over 2 ln of t times e to the c, right? That's if you know your properties. And e to the c is just simply c. So this is just this constant, okay? So let me write that here. We have w equals to t to the 3 over 2 times c, okay? Now, we made w equals to v prime, okay? So let's make that substitution back. Let me write this c in the front, okay? So now, if you want to get v, you're going to have to integrate this side. C t to the 3 over 2. Okay, when you integrate this side, you get c. The constant comes out. And you have t to the 3 over 2. So now, what happens when you integrate this? You add 1. So let's add 1. 1 is going to be 2 over 2. So 2 over 2 plus 3 over 2 is going to equal to 5 over 2. So it's going to be t 5 over 2, right? And then we divide it by 5 over 2, which is simply 2t 5 to the second divided by 5, right? Because if you divide by a fraction, you multiply, you're actually multiplying this by its reciprocal. So then this is going to be, and then the c, well, this is going to be plus k, constant, okay? Okay, then the c gets distributed out. So let's see, v equals to 2/5 t 5 over 2, and let's just say c here plus c times k is just going to be you know, it's just constant times constant. It's still going to be constant. I'm going to call this constant m, okay, constant m. So we have our v. Now in the beginning we wrote that y equals to v times y prime. Okay, same thing as not y prime, it's y1 times v, and y1 was t to the negative 1, right? Now, what is our v? We said our v was c times 2/5 times t to the 5/2 plus m. Okay, so then if we distribute, what happens here? When we multiply, we're going to subtract 1 from here, and 1 is 2/2, so it's going to be t to the 3/2, 2/5 c, and then we want to also multiply here, distribute property, plus m t to the negative 1. Okay, so this is your first y1, and this is your second y2. Okay, and then this is a constant, so a constant times this base is going to be your y2, and this constant times this base, we don't know what base, we don't know what constant it is, but a constant times the base of t to the negative 1 is y1, and the constant of this base is y2. Alright, I hope this helped you out, and good luck studying.